All right, so now we've got some radical equations where the radical is not isolated. So the first thing we're going to want to do is isolate this. Otherwise, when we try to square both sides, things are going to get really gross. So again, we want to isolate this. So this needs to go to the other side. So plus z on both sides. So square root of 81 minus z equals z plus 9. Okay, so now what we have to do is we have to square both sides. Now the left side is going to be really easy. We're squaring something that was already in a square root. So we get 81 minus z. Squaring this binomial is a little trickier. Now, if you watched my last video, you know that there's a shortcut here that's going to help us out a lot. We're going to square the first one. We're going to square the last one. And then multiply and double. So 9z, and then double that is 18z. Okay, now this is a little frustrating because now we have this quadratic that we have to solve. So I'm going to go ahead and move everything over to the right side. Should be a little easier that way. So we wind up with 0 equals, I'm going to subtract 81 from both sides. Those should cancel. I'm going to add z to both sides. So that should be 19z. So we added a z here. We subtracted an 81 here. And now we're left with this. Now, since this is a binomial, we should be able to use either difference of squares or greatest common factor. I see a greatest common factor, z plus 19. Okay, well, z equals 0, z plus 19 equals 0, so z equals negative 19. Okay, so my two solutions are 0 and negative 19. Wait. We need to check these solutions and make sure they work. So I'm going to go ahead and put the 0 back in. So the square root of 81 minus 0 is 9. 0 plus 9 is 9. 0 is a valid solution. Negative 19, okay? So 81 minus negative 19, that's 100. So square root of 100 is 10, okay? Negative 19 plus 9 is negative 10. Those are not equal, okay? So if you didn't follow along with all that, all I was doing, I was plugging these into our original equation to see if it was actually a solution. So the 0 was a solution, the negative 19 was not a solution. So on your homework, if it asks for the solution, you need to only put 0. If you put negative 19, it's going to yell at you because you lied. Negative 19 is not a solution. Okay, let's try one more. Again, the radical is not isolated. So let's get that by itself. Okay, I'm going to write that as x plus 9, just because that's how we're used to seeing it. Again, to undo this, I'm going to square both sides. All right, so square both sides. This is going to be 1 minus 6x. And then we're going to use our pattern here. Multiply these, we get 9x. Double it, we get 18x. All right. Now we have a quadratic that we have to solve. So I'm going to move all this over to one side. Minus 1, that's going to give us 80, plus 6x, that's going to give us 24x. So now we can solve this any way that we want. We could use quadratic formula, but this is factorable. So we get x plus 4x plus 20. These add to 24. These multiply to 80. So x plus 4 equals 0. That means x equals negative 4. X plus 20 equals 0. That means x equals negative 20. So now we need to double check that these are both valid solutions. So if I plug these in, I get 1 minus 6 times negative 4. That's so 1, here, I'll write it down. 1 minus 6 times negative 4 minus negative 4 equals 9. So 1 plus 24 plus 4 equals 9. Five plus 4 equals 9. That is a valid solution. Now we need to check on this negative 20. Okay, so 6 times negative 20, that's, negative 6 times negative 20 is 120. So we get 121 plus 20 equals 9. This looks not valid to me. So 31 doesn't equal 9. So this is an invalid solution. Again, I did all that by hand. You could just shove that in a calculator and check it real fast. But the key is you need to check because one of the solutions is probably not going to be valid.